Why does that look so weird, Jordan?
I don't know, Alicia. What's wrong with it?
I think you need to use the golden ratio.
What's that?
The golden ratio is an irrational number, approximately 1.62. Two quantities are in the golden ratio if the ratio of the sum of the quantity to the larger quantity is equal to the ratio of the larger quantity to the smaller one.
Oh, I get it. More specifically, this figure illustrates the geometric relationship that defines this constant. For example, the total length A plus B is to the length of the longer segment A, as the length of A is to the length of the shorter segment B.
For example, this looks really bad because there aren't any golden rectangles in it.
Oh, what would one look like with a golden rectangle? Look at this drawing. It has golden rectangles in it. The golden rectangles are used naturally in nature and therefore nice to look at.
The drawing of a man's body in a pentagram suggests relationships to the golden ratio.
Symbols of the sun and moon are in the center, while the other 5 classical planets are around the edge.
In art, especially architecture, the golden rectangle is used because it is appealing to the eye. The ratio of the longer side to the shorter side is the golden ratio, as our poster shows. For example, the Parthenon's facade are circumscribed by golden rectangles. How would one construct a golden rectangle? Number 1, construct a unit square. Number 2, draw a line from the midpoint of one side to the opposite corner. Number 3, use that line as the radius to draw an arc that defines the long dimension of that rectangle. This is the Parthenon. Everything in life exhibits the golden ratio, otherwise nothing would be appealing to the eye. For example, these shells on the beach have golden rectangles inscribed in them.
Here is a spiral drawn in the squares, a quarter of a circle in each square. The spiral is not a true mathematical spiral, since it is made up of fragments which are parts of circles and does not go on getting smaller and smaller. But it is a good approximation to a kind of spiral that does appear often in nature. Such spirals are seen in the shape of shells, of snails and seashells, and as we see later in the arrangement of seeds on flowering plants too. The spiral in the squares makes a line from the center of the spiral increased by a factor of the golden number in each square. So points on the spiral are 1.618 times as far from the center after a quarter turn. In a whole turn, the points on a radius out from the center are 1.618 to the fourth equals 6.854 times further out than when the curve last crossed the same radial line. Plants grow new cells in spirals, such as this pattern of seeds in the beautiful sunflower. The spiral happens naturally because each new cell is formed after a turn. One very famous piece, known as the Mona Lisa, painted by Leonardo da Vinci, is drawn according to the golden ratio. The golden ratio is 1.618 and has been coined golden because it is said to be aesthetically pleasing. The golden proportion can be found throughout the human body. A golden rectangle is simply a rectangle with dimensions that reflect the golden ratio. The Mona Lisa has many golden rectangles throughout the painting. By drawing a rectangle around her face, we can see that it is indeed golden. If we divide that rectangle with a line drawn across her eyes, we get another golden rectangle, meaning that the proportion of her head length to her eyes is golden. There are other golden rectangles that can be drawn on the rest of her body, like from her neck to the top of her hands.